Howdy. This video will focus on simple rational functions. Now, the vocabulary for simple rational functions. We have our rational expression, which is the quotient or fraction of two polynomials. So 1 over x would be a rational expression, and let's say x plus 1 over x minus 2 is another rational expression. Now, a rational function is a function defined by a rational expression. So we would have f of x equals 1 over x would be a rational function. And then h of x equals x plus 1 over x minus 2 would be a rational expression, would be a rational function. Now, asymptote, we've seen this before. It's a line that a graph approaches but does not touch or cross. Okay? Now, parent's rational function is going to be f of x equals 1 over x. Now, any function of the form g of x equals a over x has the same asymptotes, domain, and range as the parent function. So, let's say we had 5 over x. That had the same asymptotes, domain, and range as the parent function. Now, our parent function 1 over x looks just like this here. This is our parent function. And our asymptotes would be x equals 0 and y equals 0, or in other words, x and y axis. This would be y equals 0, and this would be x equals 0. Now, graphing translations of simple rational functions. We have our form y equals a divided by x minus h plus k, where h translates the graph left and right. So if we have a negative h, that will move right. And if we have a positive h, that would move left. And then k translates the graph up and down. So if we have a negative k, that goes down. If we have a positive k, that moves up. So our translation examples. Here we have our parent functions, here and here. Our parent function graph. So if we have a negative 2 here, that's a negative h, so that's going to move right 2. And then we have a positive 3, so that's going to go up 3. So from our center, which is going to be 0, 0, you're going to go right 2 and up 3. Alright, so pretty much your new equations would, your new graphs would be here and here. Alright, now our other equation, we have a plus 1, so it would move left 1, and a plus 4, which would be up 4. So from our parent function, which starts at 0, 0, we're going to go left 1 and up 4. So then your equation, your graph, would be right here. Now we have our vertical and horizontal asymptotes with form 1. Now form 1 will just be right there. So y equals a divided by x minus h plus k. With your vertical asymptote being x equals h, and your horizontal asymptote being y equals k. So for your vertical asymptote, just set whatever the bottom is, so whatever your denominator is, equal to 0, and solve for x. So yeah, if you add x minus h equals 0, add h to both sides, and x would equal h. Then your horizontal asymptote will just be whatever is added to the outside, or subtracted, whatever. So vertical and horizontal asymptote examples. So what are the vertical and horizontal asymptotes of the following? So our first example, we have f of x equals 1 over x minus 2 plus 3. So for your vertical asymptote, you'd set your denominator equal to 0 and solve for x. So x minus 2 equals 0. Add 2 to both sides. X equals 2 is your vertical asymptote. your horizontal asymptote, you'll have plus 3 on the outside, so y equals 3 is your horizontal asymptote. For your second example, we have 1 over x plus 1 plus 4. So set your bottom equal to 0 for your vertical asymptote, so x plus 1 equals 0. Subtract 1 from both sides, and you'll have x equals negative 1 as your vertical asymptote. Your horizontal asymptote, you have a plus 4 on the outside, so you would have y equals 4. Now your vertical and horizontal asymptotes form 2. Your vertical asymptotes, again, set your denominator equal to 0 and solve for x. Then your horizontal asymptotes would be y equals a divided by c, or air conditioner, whatever. Now, so here's some examples. We have 2x plus 1 over 2x minus 6. For your vertical asymptote, set your bottom equal to 0 and solve for x. So 2x minus 6 equals 0. Add 6 to both sides. You'll have 2x equals 6. Divide by 2, so you'll have x equal to 3 as your vertical asymptote. Your horizontal asymptote, or ha, you'll have a divided by c, which is going to be, a will be 2 and c will be 2, so 2 divided by 2 is going to equal 1. So your horizontal asymptote will be y equals 1. Next example, we have 6x minus 1 over 3x plus 3. For your vertical asymptote, set your denominator equal to 0, so 3x plus 3 equals 0, and solve for x. So minus 3 from both sides. So you'll have 3x equals negative 3. Then divide by 3, and you'll have x equals negative 1. Now for your horizontal asymptote, it's going to be a divided by c. So a equals 6 and c equals 3. So 6 divided by 3 equals 2. Domain and range. Domain will be all real values except for h, your vertical asymptote, and will be written as x such that x is not equal to h. Your range will be all real values except for k, your horizontal asymptote. So you'll have y such that y is not equal to k. Next, some examples. So your domain is going to be all values except for your vertical asymptote. So if you find a vertical asymptote, for example 1, we set your bottom equal to 0. So x minus 3 equals 0. Add 3 to both sides to solve for x, and x will equal 3. So therefore, your domain will be all numbers except for your vertical asymptote, which is x equals 3. So pretty much you'll have x such that x is not equal to 3 as your domain. Now your range will be all numbers except for your horizontal asymptote. So find your horizontal asymptote, which is a divided by c, which is 2 divided by 1, which is 2. So all numbers except for your horizontal asymptote, you'll have y such that y is not equal to 2 as your range. Now your domain for example 2. Remember, find your vertical asymptote. So set your bottom equal to 0. X plus 3 equals 0. Subtract 3 from both sides. You'll have x equals negative 3. So your domain would be all numbers except for negative 3. And your range will be a divided by c to find your horizontal asymptote. So a divided by c will be 1 divided by 1, which just equals 1. So your range will be all values except for 1. And ladies and gentlemen, that is it for this PowerPoint. Thank you all for watching, and next video we're jumping into general rational functions, which is a lot more intricate. Okay, bye guys.